Part two of lesson 4.3. We are going to move down here, and yes, I made another little typo. Please change that phrase there, the powers, to product. All right, we're taking a power of a full product. And now to just continue our conversation from yesterday and then the day before, if we have something like this, right, we know the W there is the base. We know the 3 is the exponent. We know that whole thing, the W and the 3, is called the power. And then if we just look at the 2 out front, that's the coefficient. And if we look at the whole thing, we can call that a product or a monomial. So we're going to then today take a power, make a power of that whole product. Okay, so we're taking a power of a product. So we're putting an exponent outside of a whole product. Okay, so what is going to happen there? Well, we'll explore a little bit. I know. Just give us the rule, Mr. Woodworth. Sorry. We're not going to do that. So let's look down here. Let's look right here. All right. How many different ways can we write this? Well, don't worry about it. You don't have to do it. I just want to talk through it. All right. So we can think 4x to the second to the third. That whole thing we need to use as a factor. How many times? 3 times. All right. So all of these rules kind of build on each other. All right. So now we know that the coefficients, all the 4s are all the coefficients. We can kind of we can break those off, right, to just show that they're multiplication. And then we can use commutative property to put all the coefficients together. And we can put all of the exponent, all the powers that have the same base together. And hey, look at that. Did I put too many 4s? I did put too many 4s. Let's get rid of that one. Okay. All right, we have 3 4s and 3x squareds. See that? 3 of those and 3 of those. We end up with 3 of each of those factors inside of that product. All right, so how would we simplify that? Well, we know that this is x, 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 x. All different ways to write these things, but how many total x's then do we have? We have x to the 6th. And then we have, how many total of these do we have? We have 4 to the 3rd, right? And we can just go ahead and multiply that. We get 64x to the 6th. All right, so we can think it through, kind of make it just expand it all the way, use some of the properties we know, and then simplify it back down to its simplest form here. Or we can kind of use that to help us get to a shortcut. Okay, so we can use what we just did in expanding it to help us get to a shortcut. So what we can do here, we can think of it as 4 to the 1st x squared. All right, any number or variable that does not have an exponent, we assume that is an exponent of 1. So there we have it. Now, what we can do and what our rule is we need 3 sets of that many 4s. So 3 sets of 1 4. So that would give us 4 to the 1 times 3. And then we also need 3 sets of x to the 2nd. So that would give us 3 2s, right? 3 sets of 2 x's. So then we get 4 to the 3rd and x to the 6th. And we know that 4 to the 3rd simplifies down to 64. Now, you might be thinking, wait, how do we know if we actually calculate the 4 to the 3rd and get 64, or do we just leave it as 4 to the 3rd? Because we kind of did both in our other lessons. So this time in these problems, let's calculate it all the way down, or simplify it all the way down to it's just an integer, 64. So not with an exponent. All right? So that's our rule. With numbers, we can do the example. All right. We can use a bunch of different examples, but let's try this one. 2x to the 3rd, and take that product to this power, right? So then what do? We can slide a little exponent. That doesn't have an exponent, so we'll put a 1 there. We're going to distribute it so we get 2 to the 1 times 4, or just 2 to the 4th, and x to the 3 times 4. So that gives us 2 to the 4th, x to the 12th, which gives us 16, 8, x to the 12th. There we go. All right. No, it's 16. What am I thinking? There we go. 16x to the 12th. And when we are doing it with variables, all right, we end up with a, b to the m. Well, that gets us a to the m, b to the m. All right, we just take that exponent into the others, and if we want to make sure we get it, it's going to be whatever. If it doesn't have one, it has an exponent of 1, so it's 1 times m, 1 times m. All right, but the key is that it gets taken to both of the factors inside. All right, or all of the factors inside. Okay, so let's do some practice problems here. We have 4p to the third to the fourth. What do you think, everybody? Well, how many 4s are we going to have? We're going to have 4p to the third times 4p to the third times 4p to the third times 4p. 4p to the third, right? So that ends up giving us 4 4s and 4 sets of 3, right? 4 sets of 3p's. Or we do 3 plus 3 plus 3 plus 3, but isn't it easier just to do 4 sets of 3? Okay, so we end up getting 4 to the 4th times p to the 12th. Okay, so the shortcut is we take that, put a 1 there, we take that in, we say 4 to the 1 times 4, and we say p to the 3 times 4. That gives us 4 to the 4th and p to the 12th. Very easy to just do 3 plus 4 and get 7 there. All right, try to avoid that. And then we get 4 to the 4th, which is 256, p to the 12th. And that is our final answer. Oh man, look at number 4. This looks fun. So what do when we have a power of a product? This whole thing is our product, and then it's a power of a product, okay? So what are we doing? Taking that to that, taking that to that, taking that to that. All right, so we're going to have -2. Notice I put those parentheses in there. To the 1 times 5. We're going to have m to the 7th times 5. And we're going to have n to the 6th times 5. All right, that 5 goes to each of the factors inside, and this gives us -2 to the 5th, m to the 35th, and n to the 30th. And then we can simplify that -2 to the 5th. I know it's going to be negative because it's an odd power, and a negative base to an odd power is always going to be negative. And then we have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, m to the 35th, n to the 30th. What do you think, everybody? Getting challenging? Well, give it a go. Try these on your own, pause, and then try these on your own, and then check your work. All right, we're back. How are you doing? Feeling good about it? Hopefully. 8 to the 1st, right? So that's 8 to the 1 times 2, and b to the 9 times 2. So that's 8 to the 2nd, b to the 18th. So that'd be 64, b to the 18th. Let's try this one. I'm going to need a calculator. All right. That 6 doesn't have a exponent. So take the 4 there, take the 4 there, take the 4 there. I get 6 to the 1 times 4. I get x to the 5 times 4. And I get y to the 11 times 4. That gives me 6 to the 4th, x to the 20th, y to the 44th. And I just need to get really quickly. Whoa, 1,296, x to the 20th, y to the 44th. Boom. And finally, put the 1 there, distribute this. It's not really called distributing, but it looks like distributing. So we've got -5 times 1 to the 3rd. I'm not going to put this in multiplication. 2 times 3, and z to the 8 times 3. And oops, I did a no-no. We need to make sure we keep our negative numbers in parentheses there. So that's going to be -5 to the 3rd, w to the 6th, z to the 24th. And we're going to go ahead and simplify the -5 to the 3rd, so that'd be -125, w to the 6th, z to the 24th. And that is our final answer and the end of our notes. And I hope you followed